Good morning, children. Yesterday, we had discussed about the distributive property of multiplication or addition, and also distributive property of multiplication or subtraction. Today, we will discuss about the properties of rational numbers closer with respect to addition. What is rational number? A rational number is in the form of p by q, where p and q are integers and q is not equals to 0. So, the rational numbers, it is nothing but numerator by denominator. Numerator by denominator, you know very well, children. So, now we will discuss about the properties of rational numbers, closer law, with respect to addition. Suppose for example, 2, 3 belongs to q, because rational numbers are represented as q. 2, 3 belongs to q. Therefore, 2 is a rational number because q can be written as 2 by 1. 3 can be also written as 3 by 1. So, therefore, 2 plus 3 that equals to 5 is belongs to q. Belongs to means the 5 is an element in rational numbers. So, 5 belongs to q. Another example, suppose 5 by 6, 9 by 6 belongs to q. That implies 5 by 6 plus 9 by 6, that equals to LCM is 6. So, 5 plus 9 that equals to 14 by 6. 14 by 6. 2 7 ja, 2 3 ja, that equals to 7 by 3 belongs to q. 7 by 3 belongs to q. So, 5 by 6 is a rational number, 9 by 6 is also a rational number. Their sum 5 by 6 is 9 by 6, that is nothing but 14 by 6 or 7 by 3 is also a rational number. Suppose take another example, minus 2 minus 3 belongs to q. Minus 2 minus 3 belongs to q. That implies minus 2 plus of minus 3. Minus 2 plus of minus 3 equals to minus 5 is belongs to a rational number, because minus 5 can be also written as minus 5 by 1. So, according to this property, 2 plus 3 equals to 5. If you take 2 and 3 are two rational numbers, 2 plus 3 equals to 5, because 2 by 1 plus 3 by 1 that equals to 5 by 1 belongs to rational number. 5 by 6 and 9 by 6 belongs to q, then 5 by 6 plus 9 by 6 equal to 6 is the LCM. So, 5 plus 9 that equal to 14 by 6, 7 by 3 belongs to q. Minus 2 comma minus 3 belongs to q, therefore minus 2 plus of minus 3 equals to minus 5 belongs to q is also a rational number. So, according to this property, we concluded that sum of any two rational numbers is always a rational number. Therefore, sum of any two rational numbers, sum of any two rational numbers is always a rational number. Is always a rational number. So, sum of any two rational numbers is always a rational number. Therefore, for all a comma b belongs to q, then a plus b belongs to q. For all a comma b belongs to q, a plus b belongs to q. This is which property, children? Closer law with respect to addition. Closer law with respect to addition. So, for all a comma b belongs to q, so a is a rational number, b is also a rational number, then a plus b is always a rational number, because it is a by 1, b by 1. Or otherwise, you can write like this: a by b, comma c by d belongs to q. That implies a by b plus c by d is also belongs to q. Therefore, closer law is satisfied. Closer law is satisfied for rational numbers satisfied for rational numbers with respect to addition. Now we will check properties of rational numbers, closure law with respect to subtraction. Suppose let us take two examples, 7 and 6 belongs to Q. 7 and 6 belongs to Q. Therefore, their difference means that implies 7 minus 6 equals to 1 belongs to Q. 7 minus 1 equal to 1 belongs to Q. Otherwise, in the same way, 6 minus 7 that equals to minus 1. This also belongs to Q. Belongs to means minus 1 is an element in rational numbers. Because minus 1 is an integer, so all integers are the subset of rational numbers. You know very well. Natural numbers are subset of whole numbers are subset of integers are subset of rational numbers. Okay children? So minus 1 belongs to Q. One more example. 1 by 2 comma 3 by 2 belongs to Q. That implies 1 by 2 minus 3 by 2 that equals to, here 2 is the LCM, then 1 minus 3 that equals to minus 2 by 2, 2 1 jar that equals to minus 1 belongs to Q. Minus 1 belongs to Q. One more example children. Minus 3 comma minus 5 belongs to Q. That implies minus 3 minus of minus 5, because minus 3 is a rational number, minus 5 is also a rational number. Their difference means again minus, that equals to minus 3 minus into minus plus 5. So that equals to minus 3 plus 5, how much children? 2. 2 belongs to Q. 2 is nothing but what? 2 by 1. That implies 2 is can be also written as 2 by 1 belongs to Q. 2 by 1 is belongs to Q. So according to subtraction, closure law is satisfied for rational numbers. Closure law is satisfied for rational numbers. Therefore, for all A comma B belongs to Q, that implies A minus B belongs to Q. So, the difference of two rational numbers is always a rational number. Therefore, we concluded that the difference of two rational numbers is always a rational number. So, the difference of two rational numbers is always a rational number. Therefore, closure property or closure law is satisfied. Closure law is satisfied for rational numbers. With respect to subtraction. So, properties of rational numbers. So, closure law is satisfied for rational numbers with respect to addition and subtraction. Now, we will check multiplication. So next one is multiplication. So for multiplication, let's take two numbers from the set of rational numbers, because you know rational numbers, that is q equals to set of p by q, where p comma q belongs to z and q is not equals to 0. This is the definition of a rational number. So multiplication. Take two examples. 7, 9. 7 and 9 belongs to Q. 7 and 9 belongs to Q. So 7 is a rational number, 9 is also a rational number. So 7 can be also written as 7 by 1, 9 can also be written as 9 by 1. Therefore, that implies 7 into 9. 7 into 9 equals to 63 belongs to Q. 63 belongs to Q. This is the symbol belongs to. Belongs to means 63 is an element in rational number. Belongs to. We call it as belongs to. What is the meaning of belongs to? The element or the number is in the set of rational number. Next one is another example. 5 by 9, comma 2 by 9 belongs to Q. So if 5 by 9 is a rational number, 2 by 9 is also a rational number, then their product 5 by 9 into 2 by 9, that equals to multiply the numerators and multiply the denominators, that equal to 5 2s are 10 by 9 9s are 81. So 10 by 81, 10 by 81 is belongs to Q. So 10 by 81 is also a rational number. Next example, minus 4 and minus 7 belongs to Q. That implies minus 4 into minus 7, that equals to minus 4 into minus 7, minus into minus plus 4 7s are 28. So 28 is belongs to Q. 28 can also be written as 28 by 1. So it is nothing but P by Q form, or numerator by denominator. This is also belongs to Q. It is also a rational number. And one more example, children. Minus 9 and plus 3 belongs to Q, because minus 9 is a rational number, plus 3 is also a rational number. Why? Because minus 9 can be also written as minus 9 by 1, plus 3 also can be written as plus 3 by 1. So that implies their product minus 9 into plus 3, that equals to minus into plus minus 9 3s are 27 is belongs to Q. So minus 27 is also a rational number. So minus 27 is also can be written as minus 27 by 1. Minus 27 by 1. So minus 27 is also a rational number. I repeat, children. 7 and 9 belongs to Q, means 7 is a rational number, 9 is also a rational number. Their product 7 into 9 equals to 63 is also a rational number. Next, and one more example, 5 by 9 is a rational number, 2 by 9 is also a rational number. Then their product 5 by 9 into 2 by 9 equals to multiply the numerators by multiply the denominators. 5 into 2 by 9 into 9, 5 2s are 10 by 81 belongs to Q, is also a rational number. Minus 4 is a rational number, minus 7 is also a rational number. Then their product minus 4 into minus 7. Minus into minus plus 4 7s are 28. So plus 28 by 1 belongs to Q, is also a rational number. Next, minus 9 and minus plus 3 belongs to Q, means minus 9 is a rational number, plus 3 is also a rational number. Why? Because minus 9 can also be written as minus 9 by 1, plus 3 can also be written as 3 by 1. So their product minus 9 into plus 3, minus into plus minus 9 3s are 27 belongs to Q. So minus 27 is also a rational number. So children, we concluded that the product of any two rational numbers is always a rational number. So now we concluded that the product of two rational numbers, the product of two rational numbers, the product of two rational numbers is always a rational number. So the product of two rational numbers is always a rational number. Therefore, for shortest notation, for all a comma b belongs to Q, that implies a into b are also written as AB. So AB is belongs to Q. AB is belongs to Q. So we conclude that closure law is satisfied for rational numbers with respect to multiplication. So closure property or closure law is satisfied. Closure law is satisfied for rational numbers. Closure law is satisfied for rational numbers with respect to multiplication. With respect to multiplication. So the product of two rational numbers is always a rational number. Next, for shortest notation, for all a comma b belongs to Q, that implies a into b equals to ab belongs to Q. Closure law is satisfied for rational numbers with respect to multiplication. Next one is division. Next, fourth fundamental operation is what? Division. Here four fundamental operations are there. One is addition, other one is subtraction, next one is multiplication, the last one is what? Division. So for division, so let us take two rational numbers. First one is suppose 6 and the second one is 8. 6 comma 8 belongs to Q. Means 6 is a rational number, 8 is also a rational number, therefore 6 by 8 belongs to Q. So belongs to Q, or 6 by 8 can be also written as 2 3 ja, 2 4 ja, that implies 3 by 4 belongs to Q. So 6 is a rational number, 8 is also a rational number, then 6 by 8 is also a rational number. Another example, suppose 3 by 2, 5 by 9. 3 by 2 comma 5 by 9 belongs to Q, means 3 by 2 is a rational number, 5 by 9 is also a rational number. Then division means 3 by 2 is divided by 5 by 9. That equals to 3 by 2 into 9 by 5. That equals to 3 into 9, multiply the numerators by multiply the denominators, 2 into 5. 3 9 ja 27 by 2 5 ja 10. So 27 by 10 belongs to Q. This is also a rational number. So 3 by 2 is a rational number, 5 by 9 is also a rational number, then 27 by 10 is also a rational number. Next, one more example, children. Minus 3 comma minus 5 belongs to Q. That is minus 3 divided by minus 5. So minus 3 divided by minus 5 equals to minus 3 by minus 5. Minus 3 by minus 5 equals to minus minus cancel. That is equals to 3 by 5. So 3 by 5 belongs to Q. 3 by 5 is belongs to Q. Next one is one more example, children. Minus 6 comma 9 belongs to Q. That implies minus 6 divided by 9. That equals to minus 6 by 9. 3 2 ja, 3 3 ja. That equals to minus 2 by 3 belongs to Q. Minus 2 by 3 belongs to Q. So minus 6 is a rational number, 9 is also a rational number, therefore minus 6 divided by 9, that equals to minus 2 by 3 belongs to Q, is also a rational number. Therefore we concluded that closure law is satisfied. Closure law is satisfied for rational numbers with respect to division. Therefore for all A comma B belongs to Q, A by B belongs to Q. Therefore closure law is satisfied for rational numbers. Clausen law is satisfied for rational numbers. Clausen law is satisfied for rational numbers with respect to division. With respect to division. Okay, children? So, according to Clausen law, the four fundamental operations are satisfied. Okay, children? So, now we concluded that, children, here the properties of rational numbers according to Clausen law with respect to addition, with respect to subtraction, multiplication and division is satisfied. Clausen law is satisfied with respect to addition, subtraction, multiplication and division for rational numbers. So, I hope you understand well. Thank you, children.